In example 6, we have this function. It draws this heart-shaped function, and it's called a cardioid because of its shape. And we want to find the slope at 1, 1. And it looks like the slope is about -1, but can imagine a slope through that point. So we want to differentiate this expression. Now it is there's a cubic function on the outside, and then we have squared. So we have an implicit function, and we have a few layers of embedding. We also have a product rule here that we have to be careful of when we differentiate that. So differentiating this, we're first going to work on the very outside. So we're going to differentiate the cube. So we get x squared plus y squared minus 1. And then we're going to differentiate the inside. So we get 2x plus 2y. And then because we're differentiating the y, we're going to make sure we tag on that y prime. And then that's going to be minus 0, so that's going to just look like that. I'm going to cut it off, minus. And because this is a product, I'm going to have to apply the product rule here. So when I differentiate this, I'm going to differentiate the x first, and I'm going to keep the y the same, plus I'm going to keep the x the same, and then differentiate the y, 3y squared, and then add on the chain at the end. Okay, so y prime. And that's going to be equal to 0. Now, there's a lot going on in here, so we have to try to simplify things when we can, and we have to be careful with our keeping track of our powers and all our parts. So I want to just make sure that I can kind of see the parts that I need here. I have that part here and that part here. That's the parts I'm going to try to group together for my derivative. Okay, so I'm going to first of all multiply out the square brackets. So I'm going to keep this partially factored. So I'm going to get 3 times 2x. I'm going to keep this factored as x squared plus y squared minus 1. Plus, this is going to be 6y times x squared plus y squared minus 1. And then this is where my y prime is going to show up. Then I have minus 2xy cubed minus, this is going to be 3, it looks like x squared y squared times y prime, and that's going to be equal to 0. Okay, so we have to be careful of our expressions and our signs. I'm going to group together my y primes, so I'm going to end up with y prime, and I'm going to factor out the y prime, so I'm left with 6y. And again, notice I've kept it partially factored, and you may want to multiply this all out, but whatever way you do it, you want to make sure you're keeping track of all the pieces here. So this is going to be minus 3x squared y squared. Okay, and then the other terms I'm going to put onto the other side. So I'm going to end up with positive 2xy cubed minus, so these parts are going to end up on the other side of the equation. Okay, those are terms that do not have a y prime attached to them, so minus 6x times x squared plus y squared minus 1. Okay. Again, you could maybe think of expanding some of this out if there are some like terms, but again, I don't see any like terms, so I don't see any advantage of expanding this all out. So y prime, solving for y prime, I'm going to get in the numerator 2xy cubed minus 6x times x squared plus y squared minus 1. And in the denominator, I'm going to end up with 6y times x squared plus y squared minus 1 minus 3x squared y squared. Okay, so Hopefully I didn't make any mistakes here because there's lots of things going on. So now, since I've isolated my y prime, I'm now going to find my derivative or my slope at 1, 1. So the nice thing about 1, 1 is that it is an easy coordinate to be able to substitute in. So in the numerator, I'm going to have 2 times 1 times 1 cubed. Okay, so that's going to be 2 minus, and this is going to be 6 times 1. Okay, so 6 times 1 times 1 squared plus 1 squared minus 1. Well, that's going to be 1, so 6 times 1 times 1, so I'm going to end up with minus 6 for that term. In the bottom, I'm going to get 6 times y, so 6 times 1, and then 1 squared plus 1 squared minus 1 is just 1, so that's just going to be 6, minus, so I'm going to end up with, it looks like 3 times 1 times 1, so it's going to be minus 3. So simplifying that, I end up with negative 4 over 3 as a slope through that point. So the tangent line slope through that point looks like it's going to be negative 4 over 3.